Welcome to part 1 on angles, area, arc length, and circular motion. In this section, we'll be looking at angles and their units of measure, coterminal angles, arc length in the area of a sector, and circular motion. Let's start with angles and their units of measure. If we have 2 points and we want to describe their position with respect to each other, what measurements do we use? Well, usually we'd use something like the distance formula, where you look for the distance between 2 points. If we have 2 rays and we want to describe their position with respect to each other, can we still use the distance formula? Does that change with respect to the length? An angle consists of 2 rays having the same endpoint, which is called the vertex. We can think about an angle being created by rotating one ray, the initial side, onto the other, the terminal side. So if we were to sketch this, the first ray would be horizontal and off to the right. That is in standard position. The second ray would be at an angle away from it, either calculating it counterclockwise or clockwise. In this case, we have a counterclockwise rotation, which means it will have a positive angle. We usually use this little Greek symbol theta to define that angle. And we call the first horizontal ray the initial ray, or initial side. And the second ray, the angle that's calculated up to that next ray, to be the terminal side. And if the rotation of the terminal side is counterclockwise, the angle is positive. So we indeed have a positive rotation here. If the rotation is clockwise, the angle is negative. And lastly, we'll look at the degrees here. We have 2 systems in common use for measuring the size of angles. The first one is degrees, and the next one is in radians. So I would say one of the most common uses for degrees, just in general conversation, is when you say you took your vehicle out in the snow or something and you were doing donuts, which means you were spinning the vehicle 360 degrees. I don't know, putting it in neutral or something to see if you can get it to spin when it's slippery out. I've actually done this with my vehicle, but it wasn't on purpose and it was super scary. It was in an intersection after an ice storm. So if you were to say that you did a 180, that's where you only go halfway around the circle. That's 180 degrees. So these are very common phrases, and degrees are fairly common in use when we're talking about these things. If we said that we had 1 degree, it would be one tiny little degree of the 360 total. And so it's 1 over 360, or 1/360th of a revolution. So radians are a slightly different story. If you have a circle of radius 1, and it is drawn with the vertex of an angle at its center, then the measure of this angle in radiuses is the length of the arc that subtends the angle. Now, you may not be familiar with the word subtends, but what it means is that it wraps around the point that is the center. So if we call this the center, or vertex, and actually the vertex up here would be where the 2 rays intersect each other. So in this case, the vertex is the center of the circle. Then the angle in radius is the length of the arc that subtends the angle. So here's our radius. And then as we swing this radius around the vertex, it subtends the vertex and it creates this circle. And my ability to draw perfect circles could be improved. So something like this would be the circle with a given radius, center is the vertex, etc. Now, if our radius is 1, as it says right here, the radius of 1, then what is the circumference of this circle? Well, we know that the circumference of a circle is 2 times pi times the radius. Or you could just say pi times the diameter. So if we know that's the case and we know the radius is 1, then we know that the circumference of this circle is 2 pi. Because the radius is 1, and so 1 multiplied to 2 pi is still 2 pi. The circumference of a circle of radius 1 unit circle, any unit circle, is just 2 pi. And the measure of a complete revolution, again, 2 pi. Because if you were to go all the way around this circle that I just drew, given it's just a sketch, it will give you 2 times pi, which is approximately 3.14159, etc.